Hey y'all, so I made a video about coordinates graphs. So basically we're going to talk about like the terms, how to identify different things in coordinates graphs, and then how to graph on them. So this entire thing is called a coordinate graph, right? That's the thing that it's called, I guess. Like it has x-axis right here, it's going to have a little y right here, and it's going to have this giant plus sign with all the numbers on it, right? So let's coordinate graph, right? Oops, H. That's this whole entire thing. Let me just go ahead and do that for you. Okay, and then we have the coordinate axis or axes. Let me get a different color to represent that. That's straight up just these giant lines right here. The big thick ones, they're supposed to be straight. I don't have that skill set, evidently. Okay. This thick line, it's supposed to be like the red is supposed to be right on top of those lines, but I'm just going to do it right next to it. So basically this x and this y, right? That is the coordinate axis, right? So when it goes up and down, it's called vertical. Vertical. And when it goes left and right, it's called horizontal. Hordy. Right? Let me do a different color. So this right here, this right in the center, the little bullseye right here, that's 0, 0. Dead center. That's called point of origin. So dead center, where 0, 0 is located, it's always going to be the same no matter what your graph looks like. Point of origin is always 0, 0. Okay? Let me get a different color. Red, I don't know, yellow? Should we do yellow next? So the thing is, you're going to have, you know how I have like 0, 0 right here? Well, you're going to have x, whatever x number is, you're going to have it placed there, and then you're going to have y next, and you're going to put it in these little parentheses. They actually have special names for them. You can call them x and y points. That's cool. It's no big deal. But technically, it's called, let me spell it out, ABSCISSA. That's for x, and it's pronounced abscissa. And then the y is a little bit easier. That's called ordinate. But this one's called abscissa. This one's called ordinate. So if someone just happens to like just throw that word in out of somewhere in your math class, they're talking about the x point. So like, let's say I have it like right, let's say I do it like right there. If you could see that. So on my x, it looks like it's at 3, positive 3, and it looks like it's at, it looks like it's at positive 3 on the y also. So my abscissa is 3, and then, well, that's actually a bad example. Okay, and then my ordinate also 3. Let's do it again. Let's do it again where we don't do that. Let's do it right here. Okay, cool. Let me get this eraser going. All right, we're off to a good start. All right, let's pretend that's 1, 2, 3. Okay, cool. So on my x-axis, it's right here. And then what about the y? Let's see. 2, 3, 4, 5, 6, 7. Okay, cool. It's at 7. This is 7. And then this, does it look like a 7? That looks like a 7 now. Maybe if I make it longer on the tail. And then what was this at? 1, 2, and 3? This is at 3. So my abscissa is 3. Abscissa. And then the ordinate was at 7. 7. Why? I don't know what I'm doing here. Okay, perfect. So that's a pretty good example. Here is one more thing to know. Okay, so there's 4 little boxes inside this giant box, right? Coordinate graph is the giant box, but there's 4 baby boxes inside. See how this is one box right here? Here's another one. Here's a third. And then here's a fourth. Okay, so there's actually special words for those 4 boxes. And it's called quadrant. And there's a way of numbering it. This is quadrant 1. And you're going to do it in Roman numerals. This is quadrant 2. I mean, you don't technically have to, but this is how it's going to be identified in your textbook, and this is how people typically write it. Coordinates 3 is right, well, quadrant 3 is right here. Quadrant 3. Do you want to make it traditional where we have those little tails? Quadrant 3. And then we have quadrant 4. 4 is a little bit different. It's a little bit of a V right here. This is quadrant 4. So it goes right to left, then it goes down, and it throws itself to the right. If it's a little bit confusing, just think of it like the letter C. How you draw the letter C, you start here, you stop here, you throw it down here, and then you go all the way here. C, right? For coordinate. And I mean, that's pretty much it. That's all I can think of. One more element to consider would be to look at, should I do white? On the top, it's going to be positive. And over here, it's going to be positive. Numbers, the numbers are positive. Over here, it's negative. And down here, it's negative. This whole entire row that's going up and down, that entire thing is y. And the entire thing that's laying down on the ground is x. And think of it this way. When you're sleeping and you have to get out of bed, this is you sleeping with your long feet. This is you sleeping. Okay, when you're sleeping and you have to get out of bed, you start at x, and then eventually you get up. Right? So you get up, and now you're at y. So when you're sleeping, you're at x. When you get up, you're at y. Okay. I wonder if that image was appropriate. Okay. So those are like the terms. We have coordinate graph, then we have coordinates axis. The graph is the whole thing. The axis is the whole entire thick line in red, going up and down. That makes a big giant plus sign. We have point of origin. That's that big giant green dot right in the center. Then we have the coordinates, which was the weird words we had, which is abscissa and then ordinate, right? The X and Y in the yellow font in the bottom. And then we have the coordinates, which is the giant letter C, which is 1, 2, 3, and 4 in Roman numerals, right? And we know what the plus and minuses are. And remember, X is when you're laying down, Y is when you're sitting up. Hopefully that's notable in your memory. So when you're messing with this graph, you're basically going to have something called linear and nonlinear. Linear looks like this. It's just a bunch of lines, right? Nonlinear is going to look like different shapes. It's going to be wiggly, essentially. It's going to look a little bit wiggly. So how do you know what is considered linear and what's considered nonlinear? Well, there's actually a set of rules. So if the variable it rises to the power of 1. Remember, a variable is the alphabet, right? X, Y, Z, right? If it rises to the power of 1. So this, for example, would be linear. Let's say it looks like this. That's linear. Let's say it looks like, let's do Y plus X equals 30. Okay, that's linear. If there's basically an invisible 1, it's linear. What about nonlinear? By the way, this is basically the only rule, right? Y equals like 4. That's linear. Yeah, so nonlinear, it's going to look like this. It's going to look like that. Something wiggly, something basically bent, nonlinear. Well, there's a handful of rules. So the variable, which is the alphabet, variable rises to the power of 2 or more. That's one of them. So what does that mean? Well, it could look like this. It can look like this. It can look like this. You see that little baby number floating at the top? The exponent is huge. It's 2 or more, right? We know it's going to be wiggly. What else? Well, it's division by a variable. What does that look like? Maybe 7 over like x, right? And so when you're trying to isolate things, how about plus 2 equals y? And let's say you're trying to get x by itself. Well, you're going to have to divide or multiply, right? You got to do this little guy. So it's an indicator that it's going to be a wiggly outcome, like when you draw and sketch it. Okay, what about the next one? A variable. Yeah, let's do this one. Variable with square root. So if you get something where you end up with like a square root, or I guess even better yet, let's say you have one of these, plus 3, I don't know, equals y. Well, when you're trying to get everything by itself, you're eventually going to have to square root stuff, right, to get rid of that 2. So, well, we started off with that 2, and then we have a square root. It's going to be bendy. It's going to bend at some point. It's going to be non-linear. And if you take 2 variables and multiply them together, variables multiplied together, let's try it together. So if you have like, say, x, y equals 47, right? They're being multiplied together. It's going to be bendy. So you have linear and then you have nonlinear. With nonlinear, it's literally anything. It's like straight up anything is going to be nonlinear. But if it just looks like a straight line with no little alphabets or numbers being thrown up and down, it's just a straight line of text, nothing for your nth degree, then it's basically just about almost always understood that it's going to be linear. But you have to look very carefully because, look, these variables multiplied together, they're going to look like it's a straight line. Visually, it's going to look like that, but it's not, right? So let's try some examples. Okay, so I have these 6 examples, and we're going to try to guess if it's linear or nonlinear. Do you want me to rewrite the rules? So if it's linear, it's going to have the variable risen power of 1. Okay, that's the rule for linear. What about nonlinear? Nonlinear. Okay, so if it's the variable is 2 or more, right? If it's using division, and this is always talking about variables. The topic is always variables. If we're using square root, or you will eventually end up using square root. Like if you're messing with square root at any point, it's gonna be bendy. And if it's being multiplied together, multiplied together, ER. Okay. So those are the rules. We have 4 rules for nonlinear, which is just like a wiggly little line. And then linear is going to be like straight up, like just no curves. It's a straight, just dead ahead. Okay, so we have this first example right here, which is x minus 5 equals 5. Is this linear or nonlinear? Well, our rules say that if it's risen by the power of 1, then it's linear. So it looks like there's that invisible 1 up here. There's only one variable. Remember, a variable is the alphabet. If it's just a number naked by itself, just hanging out, that's called a constant. So the only thing we're paying attention to is the x. So it looks like this is linear. We'll just do an L for linear. Let's do L for linear. What about the next one, which is x plus 5 equals y? There's 2 variables. Let's look at both of them. Okay, it looks like both of them have an invisible 1. There's no 2's. There's no division fraction stuff. There's no square roots. The x and y are not next to each other. So I'm going to guess that's linear. It looks like it's going to be linear. All right, what about the third one in the bottom? I have x squared plus y equals 3. Well, let's take a look here. We're just paying attention to the variables. The 3 might as well be dead. We're not even looking at him. He's gone. He's out of our lives. Okay, let's see. I have a 2 and I have a 1. So there's different things going on. So which one could that mean? Because this one is telling me it's linear, but this one is telling me it's nonlinear. So which one do I pick? We're going to pick nonlinear. The reason we're picking nonlinear is because this is straight. This is a straight line, but this is curved. The second it's going to curve at any point, you pick that one, right? The second it starts curving, it's no longer a straight line, right? So if I pour a cup of diet soda, it has 0 calories. If I take like a bunch of sips out of it and then I fill it up with like regular Dr. Pepper, man, there's calories in it. It's no longer diet soda. Yeah, there's just a few calories compared to a whole cup of Dr. Pepper, but it's still technically calories. It's still just now Dr. Pepper. It's no longer diet Dr. Pepper. You feel me? So this started out as diet soda and it ended up being just regular soda because of that curve. So it's not up to us. It's up to the math gods. So this is non-linear. What about this next guy? X times y equals 0. Well, I have this 1 over here and I got this 1 over here. Is it possible that it's linear? Well, let me look at my rules for nonlinear. A variable is 2 or more. Okay, it does in fact have 1, so it's still linear. There is no division, so it's still linear in my head. Square root? No, there's no square roots. I don't got to mess with square roots, so it still feels like it's linear. But what about this? Multiplied together. Yeah, these two are in fact being multiplied together. Okay, never mind. I guess it's nonlinear. That's what's happening. What about this next one? I have x plus 5 over y equals 0. Okay, let me find the variables. I have x and y. This is a 1 right here. This is a 1 right here. So it feels like it's following the linear code. Is it possible that it's in club nonlinear? Let me take a look. Variable is 2 or more. No, it's just 1. Division. It is in fact being divided. It is. It's going 5 divided by y. Yeah. Okay, never mind. It's nonlinear. He's in nonlinear club. Okay, we're doing well. Let's do the last one. I have y equals x plus 7. Let me find my variables. It's x and y right here. 7 is dead to us. Let's see. I have an invisible 1 in both of these. So let me check. So far it's passing the linear test, but could it be in club nonlinear? Let me see. Let's see if there's like a secret membership that we don't know about. Variable is 2 or more. No, it's just 1. There's no division, so we can count that out. There's no square root. It doesn't look like I'm going to mess with square root in the future. X and y is not being multiplied together. They're separate beings. They're like divided or separated by that equality symbol. So yeah, it looks like this is in fact linear. It is not the nonlinear side. It is club linear. So this guy is linear, this guy is linear, this guy is linear. This one is nonlinear, nonlinear, nonlinear. So do you see in the circles where there's linear, it just looks like just standard text, nothing weird, nothing tricky. It doesn't look like kind of like layered on. See how this kind of looks layered? This is layered. These kind of look a little bit pushed together. If it looks a little bit cluttery, there's a chance it might be nonlinear. There's a pretty good chance it might be nonlinear. If it doesn't look cluttery, there's a chance it could be linear. Just looking at it is not always bulletproof. You kind of have to memorize at least these right here, right? So this is a way to kind of just look at it without having to sketch it out. However, there's going to be many, many opportunities or I guess obligations for you to sketch this stuff out. Sometimes you can't just glance at it. You got to sketch it out. You got to know that this is going to look a certain way and what way will it look, or this guy has it look a certain way. I'm going to show you how to do that. It's not that time consuming. It's pretty quick, especially if you're allowed to use a calculator. Sometimes they're not cool with that. Sometimes they won't let you, but if you can somehow get away with a calculator, it makes it that much faster. but not by much, maybe a few seconds or a few minutes. It's not going to be like 3 hours versus like 40 seconds. So it'll save you some time, but not a crazy amount. So don't feel like you're being cheated out of something because you can't use a calculator. It's just going to save a few minutes. So basically what we're going to do is we're going to pick either X or Y, and we're going to basically put in like random numbers. It doesn't even matter. And whatever comes out as the answer is going to be the second guy. So the second guy being either X or Y. So if I decide I'm going to use X and just fill in random numbers, whatever the answer is going to be Y. So it's like input, output. I pick one for input, putting random numbers, and I pick one that's going to be output. Whatever I get out on my calculator or like my pen and pencil method is going to be X and Y. Now let's go ahead and walk through it. And it's going to be any random numbers. The ones I pick typically are going to be the point of origin. Remember, point of origin is right dead center, 0, 0. And then +1, +2, -1, -2, and I keep expanding. Maybe I'll do 3, maybe I'll do -3. But these are the numbers you always want to pick, in my opinion. For the most part. Sometimes there's been times where I've taken, like, say, Calculus 3 or something, and as I'm doing this work, I can tell the graph is nowhere near the point of origin. And then I'll have to, like, kind of maybe start at, like, 57 or 103 or something like that. But in general, Algebra 1, Algebra 2, Trigonometry, Calculus 1 and 2, and my physics courses, like chemistry, stuff like that, yeah, I would say just start here. I think these numbers are chill. Maybe even expand it all the way to 5. But see, the thing is, the more numbers you put in, the more math you got to do. So just start with these 5, right? Let's do that. So which one am I going to do? I think I'm going to make the X the input. That means I'm going to make this one like 0 minus Y equals 3. All I did is copy it down. And what my goal is to isolate the alphabet, isolate the variable. Because I made the X into 0, that means Y is the variable. That's the alphabet I'm going to put all the way alone by itself. So what does that look like? Well, I'm going to do like -0, -0. You can just leave that alone if you want. It's Y equals 3. Well, I have to make sure my alphabets are positive. So I'm just going to go ahead and get rid of that 1. Wait, did I get rid of, oh, wait, I'm doing this wrong. I'm going to get rid of that 1. So it becomes -3. Y equals -3. I just moved it over. So let's see. I divided it essentially. Do you want me to show you? I was subtracting earlier. Let me erase that circle as well. Okay, so that's what I had, and I wanted to make the Y, get rid of that negative and make the Y a positive. Your alphabets, the variables is what they're called, has to be positive. What did I do? I divided. Earlier I was subtracting and then I just got messy. I wasn't paying attention. So that goes away, it becomes positive. It becomes -3. Right? So I have Y set out, but what was X? Well, we already picked X. It's right up here. It's 0. Let's do some bookkeeping off somewhere in the corner. Let's just do it like right up here. Right here in the corner. We'll do X and then Y. So what did I end up with? I picked 0. That's what I picked. And I ended up with -3 for my output. Let's do a second one. I have X minus Y equals 3. That's what I decided. That's what that was given to me. What did I decide on? I'm going to do 1. Right? So I did 0, and now I'm doing 1. I'm just going down my little box I selected. Minus Y equals 3. Well, I need to get Y by itself, so I'm going to do -1, -1. What does that leave me with? It leaves me Y, -Y equals 2. I mean, not negative, it leaves me with 1. Wait, where am I? -1, yeah, it gives me 2. Wonder what I was looking at earlier. Okay, yeah, it gives me a +2. We know it's positive because the 3 is bigger than 1. I have a video on that. I'm scared the video is going to be too long if I go through every single detail like that. So now I have to get that y by itself, I can't have it be negative. So we're going to do negative 1, negative 1. Why did I pick 1? Because there's an invisible little 1. It's an understood invisible 1 here. What does it give me? It gives me y equals negative 2. Great. So now I know that it's negative 2. And what was my x? Well, it was positive 1. That's what I selected, right? What about, okay, well, we got that one. What's the next one? How about we do positive 2 right here on my list? So I have positive 2 minus y equals 3. So let's see. I have to make sure I get the negative 2 over here. And I have negative y. And I have positive, negative, that's a 1, I believe. 3, yeah, that's a 1. I have to get that y positive. It makes it y equals negative 1. That's my y. What was my x? Well, it was 2. That's what I decided upon. So that gives me a 2, and then I have negative 1. See, this is what it's supposed to look like. If I were to like turn it in, like to my teacher, you put those parentheses and you put that little tiny comma in between. Perfect. Let's see. Now we're going to do the negative ones. Those are a little bit more trickier for people. Sometimes I don't pay attention on them, and I've been incorrect many times. So I'm using negative 1 for my x. By the way, you can just as easily put all this stuff into y and then guess what x is. We'll do the math, and then whatever comes out, that's going to be your x. But once you pick whichever one you're going to put random numbers into, you got to keep it consistent throughout. So I can't switch it up halfway and show you that it's going to come out the same, because it's like something you want to make sure that you're consistent with. So we started with x, so we have to stay in that game. So let's see. Now I'm going to do that. What do I have? I have negative y. Then we got to put that negative in. What gives me y equals negative 4. What does that give me? It gives me, let me box that. I have negative 1 and I have negative 4. Which one was that? Negative 1? Okay, we have one more to go, and that's going to be this negative 2. Negative 2 minus y equals 3. So then I'm going to do 2, 2, negative y. This gives me 5. Negative 1, negative 1. What does that give me? It gives me y equals negative 5. Great. And then my x I selected was negative 2. So I did negative 2, negative 5. Great. These are my bookkeeping guys. This is my points I'm going to put into my graph. So let's go ahead and try doing that. Let's do this first one right here. I have 0, negative 3. One thing we're doing is we're going to draw this out, and judging by the equation, what do you suspect it's going to look like? Do you suspect it's going to be linear or non-linear? I think I'm going to guess what it is, but I'm going to wait until we're done drawing, and then you can see if you guessed right. So we're going to plot this, is what it's called. So we're going to go 0 and negative 3. 1, 2, 3. It's right there. We used it, so let's cross it out. Sometimes your teachers don't want you to cross these out. Sometimes they want you to turn in like these little answers. So just see what's up with your instructor. Sometimes I just do whatever I want. I just get points taken off. Okay, so I have positive 1 and then negative 2. Okay, and then I have positive 2, negative 1. And then I have negative 1, which is all the way on the left-hand side, negative 4. Notice that I'm starting on this x right here. And then I go up or down, right? I go left and right like I'm sleeping, and then I go up and down. Then I think I just did that one, negative 4. Now I have negative 2, and I'm going to go to negative 5. Great. That's all the ones we did. And you can keep going. You can do, you can start with like -6, -7, -8, -9. You can go all the way down to -4 million. Because this goes on into infinity, and you can just keep making the chart longer and longer. But after like 5 or 6 or 10 of them, you can predict the shape. And this shape looks like it's going in a straight line. And I'm going to put these arrows at the end to indicate that it just keeps going on and on and on off the chart. So what shape is this? It's linear. It's a straight line. There's no curves. There's no bending. It's linear. So we were able to guess by looking at the equation, and we were also able to confirm or even determine what the shape was by drawing all this stuff out with math. So it was in fact linear. Let's do some more problems. Let's see what the next one holds. Okay, here's another one. We can try to guess, is it linear or is it going to be maybe like a different shape, which is called nonlinear? So there's different. So the nonlinears, there are in fact different names for it. That's called parent function. You can look it up. I'm just scared the videos are going to be too long, and then I'm gonna like bore my one single person listening to this. All right, so we're gonna play the same game, which is you're gonna basically pick either X or Y. You're gonna decide which one do I want to use as my rando numbers I put in, and then whatever my answer is going to be the second variable that I did not put random numbers in. So I guess with this one, let me think. Which one should we use? I'm going to use, let's make Y the ones that we put random stuff into. I think that'd be fun because we already did X. Yeah, so we're going to do the same numbers, which is 0, +1, 2, -1, -2. Okay, so we're going to do 0 equals X plus 2, right? And this is the one we're selecting for Y. So now we're going to guess what X is this time. So we're going to do a little bit of a different game here. Let's put it up here, X and Y, right? So let's try to figure out what it is. So I have to move everything over to the other side to get X by itself. If the answer is not X plus 2, right? The answer is not X equals 2. It's me taking the constant, which is that 2, and moving it over to the other side. So what would that look like? I would do -2, -2. Therefore, my answer is going to be -2 equals X, right? So it's actually -2. Let me move it over here, comma, 0. That's my layout, because I selected 0 to be Y. That's why I'm putting it in the back. Earlier, we were putting it in the front, but now we're putting it in the back. So the directions matter. So let's go ahead and pick something else. Let's do 1, +1, equals X plus 2. Well, I got to get that X by itself, right? So what does that leave me with? -1. So here's what here's what I selected. Here's what I ended up with. That's -1, 1. Let's try 2. Yeah, let's do 2 equals X plus 2. And I got to get that by itself. X, that gives me a 0. Okay, so what does that leave me with? It leaves me with 0 and 2. And this is all the stuff we're going to plot, or we're going to put on the graph. Let's do the -1 next. So I have Y equals X plus 2. We're going to do -1 equals X plus 2. We'll do -2, -2. That leaves me with negative. The two negatives make a 3. 2 and 3. That's my X. This is my Y. See right there? So my X is -3. Then I have -1. Let's do one more. I have Y equals X plus 2. And then the X is going to be -2. Yeah. That's cool. Let's do that. -2, -2. That leaves me with -4. And then here goes the number I picked. So it becomes, it becomes -4 and then -2. So there we go. Cool, sweet. These are the numbers I've selected. We could do more, but let's just keep it here. And let's go ahead and plot it. So I have -2 and 0. And then I have -1 and +1. So we're starting with x. If we have 0 and 2. Starting at x, 0, and then we have +2. And then I have -3, which we're starting at x on the left-hand side, and then we're going -1, which is at the bottom. Then I have -4, and we're going to go to -2, which is at the bottom. Wait, it's right here. Great. We could do more, and it's going to keep giving us little dots here, and it's going to give us more dots here, and what we end up with is a straight line again. It's supposed to be straight. I don't have that skill set, so it is linear. Hooray, we did a second one. This is exciting. Well, it looks like they're both linear. Maybe we can get it to be a different shape in the future. Let's take a look. Let's see if it goes into a different direction. Oh, here's a nice one. Let's see. We're going to have to pick one for x for randos, and then we have to either pick that or we got to pick y. Which one should we do? I want to do x for the randos. So we're going to do our numbers. My go-to numbers. You can do anything you want. You can pick anything. I just pick point of origin and then I just expand outward. So let's see. Yeah, so we're going to do y equals 0 squared plus 1. I think this is a good one because it's going to actually help us with some pre-algebra stuff as we're doing the math. Okay, so y equals 0 plus 1, which makes y equal 1. Did I do that right? Yeah. Y equal 1, and then this is what we picked for x. Let's do our x and y math here. I did 0 and then 1. Great, let's do another one. I don't know why I'm like doing so badly today with like the math. Okay, let's do 1 this time. Plus 1. Okay, so it becomes y equals 1. 1 times 1 is 1, or 1 squared is 1 plus 1, which is 2. That's my answer. And then that's my x, so then it gives me 1 and 2. Sweet. Okay, awesome. Okay, let's do let's do 2. Just do 2 up here, I guess, because we're running out of room. 2 plus 1. This gives me 4 plus 1, which gives me 5. And then here's that little guy right here. So what does that give me? It gives me 2 and then 5. Let's do the negative numbers next. I have -1 squared plus 1. So what do I get? Well, when you take a negative and multiply it against its same number or do the square root, it's actually going to be positive. So we're going to get +1. Right there. Plus 1. It's going to be y equals 2. If you do a million of these, you can immediately start telling what's going to happen. But you have to do like straight up a million. You can't even do like 10. You got to do like a million. So let's see. Because we're trying to guess like, what shape is this? You know, is it going to be linear or non-linear? What will it look like? Let's do -2 as agreed upon by our little chart thing. Plus 1. So -2 squared is going to be positive. Anytime you have a negative number and you're squaring it, it's going to end up being positive. and type it in with your calculator. If you type in the parentheses, you're going to get a positive number. What do we end up with? We end up with 4 plus 1, which gives me 5. That's our y. That's our x. Did we miss one? I feel like we missed one. Let me see which one we missed. 1, 2, 3, 4, 5. There's 5. Oh, man. Let me see. 0 and 1, 1 and 2, 2 and 5, 1 and 2, 1, 0, 1, 2, 1. Oh, I think I forgot to write this one down. -1 and 2. All right, there we go. We did all 5 of them. Let's go ahead and graph it. Now, here we have this little 2 dangling up there. So let's see, is it linear or non-linear? So I have 0 and +1. I have 1 and +2. I have 2 and +5. Is that a 5? I think, yeah. 1, 2, 3, 4, 5. Great. I have -2, +5. Then I have -1 and +2. Great. Let's take a look and see what the shape is. It looks like it's bent. Looks like it's a little bit wobbly. It's not a straight line. It's supposed to look like this. Like a parabola. So would you say this is linear or non-linear? Well, according to the rules, it is a variable of 2 or more, and then we're looking at it with our own eyeballs and we're seeing that it is in fact bent. It's not a straight line. So it's non-linear. It's non-linear. Let's try another one. Oh, this one has a coefficient. A coefficient is when there is a number in front of the alphabets. Anytime there's a number just right in front of the alphabets, it's called a coefficient. If it's at the very, very, very front of the equation, like it is right here, it's actually called a leading coefficient. And that 12, that's just naked by itself, that's called a constant. And then we have 2 variables. That's the alphabets. That's x and y variables, right? So that's the anatomy of all of this stuff. So is this linear or non-linear? Well, maybe I can try to guess. I'm looking at it. I kind of have an idea, but let's go ahead and work it out. And we already know which numbers we're going to pick. We're going to either throw it into x or we're going to throw it into y. Let's throw it into x. We're going to do 0, 1, 2, and we're going to do -1, and we're going to do -2. Those are our numbers we picked, right? Just from the dead center, and we're just expanding outward. So let's do 3. Let's do 0 plus y equals 12. Okay, cool. So what is 3 multiplied by 0? Anything multiplied by 0 is going to give me 0 plus 12. I'm going to move that 0 over. It gives me y equals 12. That's my answer, and that's my x right here, the 0. So let's go ahead and do that. Meow, meow. And then I have 0 and 12. Sweet. Okay. Let's do the next guy. I have 3 mystery number plus y equals 12. What's my mystery number going to be? 1. I start with 0, then I do the positives, and then I do the negatives. You can start any direction you want. You can just go left to right, starting with -2, ending with +2. So let's see. I have 3 plus y equals 12. I got to move that 3 over because I got to get that y by itself. What does that y give me? 9. 12 minus 3 is 9. And then we got that 1. So it gives me 1 and 9. Sweet. Let's do some more. We got that 3. And then I'm going to put like a 2 up in there. Y equals 12. That's 6 plus y equals 12. Okay, but I have to subtract 6 on both sides. So it gives me y equals +6 and a 2. So what does that give me? It gives me 2 and 6. right? So my x is 2, because that's what I threw in. That's my mystery number. And my output was that 6, which is y. Let me do another one. We're going to do the negative numbers now. So that's my mystery number is -1 into that x, or where the x was living. I took the x out and made it into a -1. -3 plus y equals 12. Then I got to do +3 to get rid of it. It gives me 15. Right? And then I pick -1. -1, 15. Okay, let's do one more. Wait. It's not a y, it's a 3. 3, -2 plus y equals 12. Gives me -6. Yeah, -6 plus y, 12. I'm going to do +6. I'm going to do +6. 18. 6 and 2 is 18. And then my x was -2, +18. 3 and 5. Great. Great. So that's all the rando numbers I picked, my mystery numbers. And then I got my output of these y's. So let's go ahead and graph it. I'm taking a look at the equation. I'm thinking, is it linear? Is it nonlinear? I have an idea, but let's go ahead and draw it and see what we get. So I have 0 to 12. I'm going to put it up here because I actually don't have it at 12. It stops at 10. So we're just going to have to guess. 1 all the way to 9. Then I have 2 all the way to 6, which I think is right here. Maybe right here. I have -1, +15. Okay, -1, +15. Let's say it's up here. And I accidentally marked it. Let me go and erase that. Okay. And then the last one is -2, and then it's all the way up at 18. Okay, great. So it looks like it's going downward this way. It doesn't look like it is bending. It doesn't look like it's bending at all. And when I look at the equation itself, it looks like there's 2 variables, the x and y, and it looks like there's ones. It's not being divided. It's not being multiplied. It's not 2 or more. There's no square roots. Okay, great. Looks like it's going to be linear. This is a linear function. That's exciting. Let's do another one. Ooh, this one's pretty good because it is all over the place. So what do I do here? It's all over the place. How do I know which variables to pick, which ones to avoid? How do I do this? Okay, well, what we're going to do is we're going to combine all the like terms. I'm going to move this guy here because they're 2 x's, and I'm going to move the constants together. I'm going to put everything together. So I have, here, let's erase these lines so it doesn't overwhelm us. So I'm going to do -2x, -2x. What does that give me? It gives me a -x right here. And then let's go ahead and get rid of this 4 and put it over here. Right? Gives me a -7. Great. So if I were to rewrite this whole thing right up here, it would give me -x equals y minus 7. That's my new expression. That's my new equation, right? So, and I just follow what I've been doing. I just pick one for my rando numbers, and then whatever comes out is going to be the leftover variable. So let's do x for ours. Let's box this so we know that it's valuable and important. I'm going to do 0 equals y minus 7. What does that give me? It gives me +7. Y equals +7. 2 positives, 2 negatives, one of it's moved over, it becomes positive. Here's my x. Let's go ahead and make the little graphy thing over here 0, and then I have 7. Great. What about, Get rid of that. Let's do another one. I had -1 equals y minus 7. Okay, let's see. I got to move the 7 over. So that's going to be +7 plus 7. What does that give me? It gives me 6. It's going to be a +6. I know it's positive because that 7 is bigger than that -1. I have a video on that in my little whatever channel thing. And then I picked +1. All right, great. We're doing great so far. Hope everyone's with me. Okay, so we did 0, we did 1. Let's do a 2 equals y minus 7. Okay, we're going to move that 7 over. Move that 7 over. Let's see. I think my screen froze. Okay, I hope you can see this. It's a 5. It's supposed to be a 5. It's 5 because 7 is bigger than 2, so we know it's going to be positive. Let's go ahead and label it. It's 2 and then +5. Okay, and then I have let's do -1. Right? So it becomes a positive, right? These two put together, it becomes positive. So we're going to do +7 here, +7 here. It becomes +8. Right? So we have -1 and we have +8. And then we have the last one, which is -2 equals y minus 7. And of course that becomes positive, these two. And then when we move this over, 7 and 2 is 9, right? So then we have -2, or we have 9. 3 and 2, it's 5, great. So we're going to guess what the shape is. I'm looking at it. I'm thinking I know what it is. It's either going to be linear or non-linear. Eventually, you'll read about the parent functions, and then there's going to be like, how do I identify which non-linear it is? But right now it's just linear versus non-linear. So let's take a look. We're going to go ahead and plot everything. So all of this is going to go on the x-axis, which is laying down because you sleep first and then later on you wake up, right? So that's how we're going to do this. So we have 0 and 7, which I'm assuming is right about here. Then we have 1 and 6. And then I have 2 and 5. We have -1 and 8, which I guess is right here. And then we have 2, and then we have 9. Cool, perfect. It looks like it's going in a straight line. And then we put it with arrows because it's going into infinity. It's just going on forever. Right? So it looks like it is linear. And when we look at the variables, we're seeing it's just a bunch of 1s. Nothing's being multiplied. Nothing's being like the two little variables are not touching and multiplying. There's no division stuff going on. There's no square root stuff going on. They're invisible 1s for the nth degree. There's no 2s or 3s or 7s or 4 millions. Looks like it's linear. Let's do this last one. This is a pretty good one because it's kind of like what goes here, what's happening. When you see something like this, when it's like x is 0 or like y is 7, x is y, when you just see something basic like this where you can't really do much, it's going to just be a straight line. It's linear. It's linear. And you can tell, you can still do the test, right? The linear versus nonlinear. Do you see how there's an invisible 1 up there? And what does that look like? It's a positive number, so you're going to go to +4 on the y-axis. The y-axis is the up and down one. You're going to go right here. And you can't go up and down you can't draw the line up and down. We can't see it. So you're actually going to go the other way. You're going to go this way. So that's the actual answer right here. This line is the answer. Let's say it said x equals 4. Let's say it said that instead. Well, you're going to find 4 on the x-axis. 1, 2, 3, 4. That's laying down. And you're not going to go draw it left and right. We can't see it. You're going to go up and down. I know it feels a little bit weird, but that's just how it goes, right? That's how it goes. So that's this one right here. So when you just see like one single variable equals a constant, you know it's going to be a flat line going either up or down or left to right. So this is how you graph equations. You basically pick one of the variables, x or y or whatever, and you just throw in random numbers. There's a way of using good numbers, which would be like 0, +1, -1. And then whatever is the answer is going to be the second variable. And all you do is plot it afterwards. So those are the steps. You just pick random numbers. Whatever the answer is going to be the other variable, and then you plot your answers. I hope this video helped to help you kind of graph and learn about coordinates planes. I do have some stickers in my sticker shop. Okay, thank you everybody. Bye.